Hi everyone. In this video, we're going to talk a little bit more about the bonding in atoms, specifically for ionic compounds, and then we're going to talk about how to name some ionic compounds. So let's start with a refresher of what a chemical bond is. So chemical bonds form by valence electrons either being transferred or shared between two or more atoms, and this will provide the atoms with a full octet. So when we've been talking about noble gas envy, we've been talking about getting 8 electrons in the outer ring, and that's what we call an octet. All right, so again, they're going to resemble noble gases and be more stable with their electrons. Now, the octet rule is a variation of the rule of zero charge. All right, the rule of zero charge tells us that cations and anions come together in the correct ratio so that we have no overall charge. The octet rule, which we will revisit more with covalent compounds, tells us that compounds form so that each atom will gain, lose, or share electrons to have 8 around it in its outermost energy level. Now, there are some exceptions. Hydrogen and helium only need a duet, and boron needs 6. We'll get into that in more detail in Unit 2. Okay, quick refresher. What's going to lose valence electrons? Well, that's going to be anything with less than 4 of them. So those would be metals, and they'll lose them all. We're going to make a positively charged ion called a cation. Right? We're not going to worry too much about the size part here, but we just need to know that cations are smaller than their neutral atom. All right, so if we look at this little example down here, we can see that our sodium starts with 11 protons, 11 electrons, and then it loses one of them. So that electron is gone. Leaving it with 10. So we've got 2, 2, 2, and 2. So 8 on the valence electron, 2 on the core. There's the charge of +1. All right, and we can see here, sorry, the little block there, that is aluminum. Loses 3 valence electrons to form the aluminum 3+ ion. Number of protons stays the same. Now, gaining valence electrons. So we need more than 4 valence electrons. Those are usually nonmetals. And they'll gain enough to have 8 on their outer energy level. We call these anions. So anions gain. So here we had an example of chlorine. Gains 1 electron to have 18 in total. Same thing here with fluorine. So 1 electron in gives it 8 on that energy level. We've got 2, 4, 6, 8, and a net charge of -1. All right, let's do a quick check-in. So we're going to start by looking at calcium. So it's in group 2. So let's zoom in and look at it on the atomic level. Take a moment to tell me how many energy levels does calcium have? All right, calcium has 4 energy levels. It has 2 valence electrons. Now the question is, does it form a cation or anion? So calcium is going to form a cation because it loses 2 valence electrons. Now, what is the charge on it going to be? Well, because the calcium lost 2 valence electrons, it's going to form a charge of 2 plus. So if we look at it after it loses those electrons, we can see it now has 3 occupied energy levels with 8 valence electrons on the outer ring. Let's check in again. This time we're going to look at oxygen. So let's zoom in on that. Oxygen is a nonmetal in group 6A. It's going to have 6 valence electrons. Will it gain 2 more electrons to get up to 8, or will it lose these 6 to have 8 on a new ring? Okay, oxygen will gain 2 electrons. So does it form a cation or an anion? That's right, oxygen is going to form an anion. Now, because it has gained 2 more electrons, what is the charge on it going to be? That's right, if you pick up electrons, your charge becomes negative. You have more electrons than you do protons. So here's oxygen with 10 electrons in total, 8 on its valence ring, but still only 8 protons, so a charge of -2. Now let's look at a visual of how the bonds form. Now cation and an anion come together to make a neutral compound. That means that there's no more imbalance between the positives and negatives. We have the same amount of each. And here we can see what happens. Energy has to go into the sodium atom to remove an electron. If we watch this animation again, so energy in, it shoots the electron over to chlorine. They come together and release energy when the bond forms. Now, these bonds are stronger than if we had each atom on their own. It's called an the process is exothermic because energy is released. This is looking at another example between calcium and chlorine to make a neutral compound. So if we see when they start, it's neutral. When we add 1 chlorine to the calcium, so let's watch this again. Chlorine needs 1 more electron. The calcium becomes +1 because it loses 1. This chlorine takes the other to make the calcium +2. Each chlorine, when it gains that extra electron, becomes a -1. You'll also notice that the calcium atom loses its extra valence shell when the atom forms the cation. All right, so some properties of ionic compounds. You can pause to read these in more detail. Important things we need to know is that they form crystals, all right, in a structure called a crystal lattice. They're made from cations and anions, and they have the following characteristics. So the crystals are hard but brittle, so they're easy to break at room temperature. They're very hard to melt and boil, so they have high melting and boiling points. But usually they can also be dissolved in water. And when they are dissolved in water, they can conduct electricity. That's what we call an electrolyte. And here's just some visual examples of the different properties of ionic compounds. Now, new part for today is how are ionic compounds named? It's relatively simple. When an ionic compound is formed, the cation, so the first one, gets to keep its name. So the cations keep their name. And the anions change its ending to IDE. So we'll look at a few examples together. So Na, if we look it up on the periodic table, is sodium. If we look up chlorine, Cl is chlorine. Now, that anion, that nonmetal, comes second, so it's going to change its ending from chlorine, so we'll get rid of that, and it becomes chloride. All right, so the metal keeps its name, nonmetal changes its ending to IDE. Let's look at another example. Ca, if we check on a periodic table, is calcium. F is fluorine. So it drops the ione and changes to ide. So it becomes calcium fluoride. Okay. Al, aluminum. O is oxygen. So aluminum keeps its name. Oxygen is the anion, so it becomes aluminum oxide. And the last example here, Ba, if we check on a periodic table, is barium. As is arsenic. So this becomes barium arsenide. Now you usually drop the last 3 to 4 letters to make the IDE. So oxygen becomes oxide. Okay, so that's what gets dropped for oxygen. Forgot to do that one earlier. Sorry. So try these four on your own. All right. So Rb2S should be rubidium sulfide. GAP becomes gallium phosphide for its name. Li3N is lithium nitride. And CaC2 is calcium carbide.